welcome viewers to the Daily Space Weather. Lots of stuff to cover, new segments, and all kinds of things going on, so let's not screw around and get right to it. By the way, if I haven't said so yet, Happy New Year to all you new and old viewers, friends and foes alike. Now, we've been running into some issues with the SDO site here. The AIA HMI browse data link is not sending us good data right now. So we're going to look at a little different format here. Here's a still image right around 9 o'clock UT today on January 2nd of SUNSPOT 2755, which for some reason is not named yet. It looks like a beta class sunspot. It does appear to have two distinct umbral areas, and they look like opposite fields to me. And I don't know. Penumbra have nothing to do with it, folks. We're just wondering why it is that this is not named yet. Perhaps folks are on vacation. And we've brought up the SDO data dashboard here just to give you some images. We'll look at 171 angstroms as well as 193 for a moment. That's a 48-hour movie there, folks. And you're going to see that sunspot there, very low latitude. At the end of the movie, I'll let that play through a second time so you can see it. And there are your time and date stamps. And let's look at the colorized magnetogram view. I apologize for the slightly lower resolution here. And it does appear that there are two umbral fields there, folks. Expecting that to be a beta class sunspot without doing a super deep analysis on it, as there's lots of other stuff to get to, including new segments like our Cosmology section. Here's the latest colorized magnetogram in high res. And you can see there is some polaric separation there going on associated with that sunspot 2755's fields. Anyway, name that sunspot. It's going to be named 2755, by the way. I didn't know if you were aware. We were talking about it yesterday already, and for some reason, everybody seems to have been overlooking it. I don't understand it. Anyway, here's the LASCO C2 image. And this is also showing us old data. And we don't have newer data from the stereo A coronagraph either. So there could be a coronal mass ejection headed toward the Earth right now, but it doesn't look like it's going to be a severe one if so. And by the way, the reason we've been using the word live in the titles, for all of you not viewing the live stream on Twitch, and good morning, Mary. For all of you not viewing the live stream on Twitch, the reason we're putting live is because we are streaming live on Twitch, twitch.tv/smAsho. By the way, welcome to the Neo Renaissance. If you haven't gone to smAshomash.org yet, check that out. Scroll down to the link to our forum, or just type in smashomash.com/forum, which will take you here. Set yourself up a login, and we're going to talk about all kinds of things from cosmology to Earth and geophysics, general science, the sun, a free-for-all, and just general forum stuff. You'll be able to post topics if you like. And let's look at the GOES X-ray flux, which is totally flatlined, despite a little bit of activity kicking up on that sunspot. 10.7 centimeter radial flux has come up from 71 to 72. Still essentially solar minimum conditions, and the solar wind speed and velocity and density are super weak, folks. Here is the KP index at 1 for the last 3 hours. And we've seen very low geomagnetic activity. We're going to skip cosmic rays today. I believe we covered them yesterday. Watch yesterday's video, or click the links in the description and check out network of cosmic ray stations and monitor them yourself. Don't take our word for it. Here's a real-time solar wind. Talk about a low solar wind density, 1.09 protons per cubic centimeter. A small uptick recently, bringing the solar wind speed off the floor. It was all the way down to the low 300s there, now up to 343 kilometers a second. There's the data from ACE looking similarly. GOES electron flux is very low. So the Van Allen belts are looking a little weak over the past 3 days. Relativistic electrons looking very low also. At the lowest part of the moderate range, really. We do see a small relaxation in the ionosphere of the anomalies over the South Pacific. We still see those anomalies there at nighttime. Not quite as extreme as we have seen. I'll let that play through. And bring up the latest image, as we traditionally do. We do still see some anomalies in the southern hemisphere there around Antarctica. Heavily charged up Antarctican continent there. But it is summer in Antarctica. And you can see some anomalous data right here on the prime meridian. There's no way the ionosphere created a blob that just mysteriously ended on a longitudinal line. GOES magnetometers are looking pretty smooth, and we're lacking data for magnetometers also. I think the SUNSPOT observatory has gone on vacation as well, as we're looking at 1 day and 9 hour old data on all of the Gong 2 stuff. So nothing to show you there, folks. I wouldn't be surprised if we saw some changes in the current sheet as a result of that sunspot. Still don't know why it's not named. It's a significant size sunspot. Let's hope folks are on vacation and we're going to be seeing the data coming back soon. University of Michigan still sending data. Here is the geospace magnetosphere movie showing magnetohydrodynamic pressure. And it's looking pretty weak, as you'd expect with such a low solar wind speed and density over the past 3 days. So quite steady as she goes, weekly. Into the dark, dark night of space, which is not empty, by the way, folks. It might be a vacuum compared to Earth. You might not have enough oxygen to breathe, but it certainly is not empty. Space is not empty. I don't know if you're aware. Anyway, here's the geospace ground magnetic perturbations, and not seeing a lot of current induced there either. Nothing too weird going on, magnetically speaking, according to this model. Looking just weak, and not a lot to really comment on there. Let's go over the earthquakes of the past 24. I'm just going to slowly scroll up. And we're only really reporting on 6+ magnitude quakes and deep quakes, folks. So, see what we have. Anything weird going on? We got some Aleutian Island chain quakes. Another one at the African/Antarctican plate boundary. Some 5 magnitude quakes in places like New Zealand and the Aleutian Islands. What is this one here? All right, that one coming in at 1651 yesterday. 5.0 magnitude. Here's a quake at 300 meters above sea level at Petrolia. Let's take a look at that one. And now that's a mysterious quake. Pretty hard for a quake to occur above sea level in the ocean, isn't it? What is up with that? It's the day of data anomalies galore, folks. The mysterious quake that occurred in the air above the ocean off the coast of California. Please leave a comment if you were out on a boat and you saw a spacecraft cause an earthquake from the air. I don't know what is up with that. That is bizarre. I can't get over that. 0.3 kilometers above sea level, but over the ocean. That makes a lot of sense. Please leave a comment if you have an opinion on that one. And let's see, what else do we have here? Here's a deep quake in Argentina. Seems like a danger zone to me for large earthquakes. Western South America, especially in that central region where we have that little kink in the land there. Seems like a bad place for earthquakes. And scrolling up the list, scrolling, we see a deep quake in Indonesia. And one coming in just as we did show prep, actually, at Kodiak, Alaska, at a 4.8 magnitude. Anyway, let's move on. Talking about Krakatoa, the latest heart on our windy.com map is the site of the deadliest volcano of the past 365 days. As this one killed, I believe, 200 plus people by producing a deadly tsunami. There was video of it all over the internet if you want to look up the Krakatoa tsunami. Happened late 2018. And I just wanted to cite it on the map so folks know where it is located. There is a location of Anak Krakatoa, which is, by the way, on the volcanic list for the past 24 hours. Or the currently erupting, I guess I should say. Anyway, here are the pressure zones. We'll let that advance 24 hours. And I will take a short break. And this is where things will be about 24 hours from now when we made the video, and we made the video at 4:30 a.m. Eastern Time. Did you know where your pressure zones were? Give me back control, Windy. Moving on to the volcano list, we see Mount Abico. Uptick there. Mount Abico producing a 10,000-foot ash plume. Mount Aso, 6,000-foot ash plume there. Krakatoa, 8,000-foot ash plume there. Back on the list once again. Tucono exploding, 7,000-foot ash plume there. Sangay issued some sort of a volcanic ash report. Revenador issued some kind of an alert. I don't know why. It's been erupting steadily for months, if not years. And Sabancaya, volcanic ash not identifiable in satellite data. Please don't hang glide over Sabancaya. And here's a lightning maps, courtesy lightningmaps.org. A great website. And it looks like we've got some lightning coming down in the U.S. Or is it going up? Baton Rouge. You better batten the hatches, as there is thunder rolling in next time you hear lightning overhead. Perhaps check out lightningmaps.org. It could save your bacon. Here's where jet streams are located right now. And this is on nullschool.net if you weren't aware. And as I let that play, I'll read the Twitch comments. By the way, thanks for leaving comments, Sugas and Mary. I appreciate that. And we are still at a net underquaking of 7+ magnitude quakes and 6+ magnitude quakes. Just because we had a few of those over the past period of time, we are still in an earthquake drought, really. And anyway, there's the jet streams of the western world. It looks like some very cold air being injected into the northwest once again. And here is the jet streams of the eastern world. Here are the jet streams of the eastern world, I should say. And I'm not really going to comment on it, although I would say that the northern hemisphere is looking a little less meridional in the east than it does in the west. Here's the U.S. Doppler radar map. Welcome to the value-added services section. And those storms down in the south-central U.S. there are butting up against a bunch of dry air. We'll show you in a minute. And we have this ribbon of dry air here going over the middle of the country, working its way up to where I'm located. And that's kind of the cold-warm air boundary right there, this little ribbon of dry air you see going all the way from the tip of Baja, Mexico, all the way up to Cape May, New Jersey. Island Beach State Park Please leave a comment if you've been to Island Beach State Park. It's the very southern tip of New Jersey. Anyway, let's zoom in on my location for once. As today I'm going to look at what's going on above my head, as I'm interested in when the temperature will suddenly rise. And once that demarcation line gets north of my location, which is around the Lehigh Valley, Pennsylvania, we should have an increase in temperature. Anyway, this weather pornography section brought to you by smAshomash.org at massive personal expense. And by the way, speaking of massive personal expense, thanks patrons for offsetting some of our massive personal expenses. Please consider becoming a patron if you haven't already done so, as we've got a lot of things to do in 2020, and we need a lot more funding to do it. Also, please press like and subscribe on YouTube if you enjoy the content. Take a moment to scroll down, patronize the channel, perhaps donate via PayPal. Share on your social media, and we'll give you a moment while we monkey around and talk about the Smash team before we move into the new segments. And by the way, thanks, Smash team. And here come the bonus segments. It's not just that is an ass and that is a hole in the ground. The vulgarity-free section, where we discuss everything from pack animals to sinkholes to anything we want. We talk about very, very fast things, such as the fastest object ever built by man, as far as we know, the Parker Solar Probe. We talk about slow things like the government and massive bureaucracies. We talk about other fast things like our own organizations and how we're making merch, such as the 3C405 shirt, which has got a radio image of Cygnus A, massive radio galaxy, as well as the link, the URL to our .org website. Let's talk about the astronomical events that will occur in 2020. Before we move on to the official cosmology section, and shout out to Alan Dyer at AmazingSky.com for this artist's rendition of spacey stuff and some driftwood. Anyway, lots of things will happen. Venus will be a favorable apparition. There will be meteor showers. There'll be us making lots of videos and doing all kinds of other things like writing papers. Opposition to Mars. Actually, lots of oppositions. Inner planets. Venus versus the Pleiades. Anyway, we left links to the article. This is the annular solar eclipse of 2019, which we didn't even really cover it because there was so much science news going on that we couldn't just be like, hey, check out the annular eclipse, as if you don't know what it is. Just another thing disproving flat Earth. And thanks to all our viewers for being massive entropy busters. That's part of the reason for our organization to exist in the first place. As in the mid-90s, I got the hell out of science because I saw the writing on the wall, and now I've gotten the hell back in because I am the writing on the wall. Anyway, welcome to the latest change to the Daily Space Weather. It's the Cosmology segment, and we will generally always have a Cosmology segment where we talk about whatever we want as it pertains to cosmology. So here's a little GIF animation here. This is just of the magnetosphere and sort of a graphical representation of what a proton does. And I'm not sure who made this one, but I need to get a photo credit for this because this is a great GIF animation. And anyway, let's talk about where things are in the solar system. Earth all alone right now on this side of the sun. Nothing else out here. although Venus and Mercury are making their way around. There's where stuff will be in 7 days, approaching the new full moon, the latest full moon, the first full moon of the decade. And here's where stuff is above my head. By the way, if you have a low horizon, check out Mars as it rises just ahead of the sun. You may be able to get some delightful images of that, especially as there is no moon up in the sky yet. And if you like the star chart here, check out in-the-sky.org. And we have no affiliation, by the way, with in-the-sky.org. But there's going to be a big pileup, as we've been seeing day in and day out. No surprises here. Let's pause it. You're going to have Mars, Mercury, Jupiter, the Sun, Saturn, Venus, and the Moon, all in the sky at the same time. Let's talk about the cosmic toolbox, polarization. Now, I've been saying for months and probably even years that stars, planets, galaxies, and indeed you form on ionization pathways. And it's not just ionization pathways, it's also polarization pathways. So please read the article. This one posted on SciTech Daily back on December 10th. A fundamental mystery of how planets form. And guess what, folks? It isn't because of gravitational accretion. We've never been able to recreate gravitational accretion scenarios in microgravity, but guess what? Glass beads stick together as a result of polarization in microgravity. So again, welcome to the Neo-Renaissance. Please join me as we watch cosmology, physics, and astrophysics get rewritten. It's going to be an interesting decade, to say the least. Shout out to Science Spies for posting this article. And while we covered it about 2 weeks ago, giant magnetic ropes seen in Whale Galaxy's halo. And how is this done, you ask? Well, it's by using radio interferometry and lots of big telescopes that are very expensive and take up hundreds of miles of square space, as they compare lots and lots and lots of data to try to figure out the way baryons are moving around. And, well, I guess I should just say photons. But in any case, these are the magnetic structures of the Whale Galaxy, otherwise known as NGC 4361. And you can see the green portions are magnetic fields oriented toward us. The blue magnetic fields are oriented away from us. And notice the coherent structure. Now, this is an edge-on disk galaxy, and we can't really see the shape of this. This thing could be a vast spiral, or it could be more or less an elliptical galaxy if we viewed it from the ecliptic plane view. And I would note the way these fields are like right next to each other and in opposition. You can see here you've got blue right next to green, green right next to blue. And the southern pole field looks totally different, indicating that there's some kind of activity probably going on at the galactic scale there. And we won't get into super deep cosmology about the magnetic fields, except to state that in the realm of cosmology, the plasma orients to the fields. The plasma isn't the fields. The plasma orients to the fields. And these fields likely extend a great distance beyond where you can see them here. It's just that there is only enough matter to illuminate where the fields are, or perhaps not enough zoom, but we are seeing background here. So in any case, read the article. Magnetic fields seem to run the universe. Now let's talk about some deeper stuff here. We're going to talk about Cygnus X3 for a quick moment. And this is what Cygnus X3 would look like if you viewed it from its edge. Now, you don't live on Cygnus X3's edge. You live inside Cygnus X3's beam. Now, this thing is not a BLAZAR. It is a We call it a massive X-ray binary, and it's one of the more interesting objects in the galaxy. Now, it is the brightest intrinsically luminous object that we see within the Milky Way galaxy. Cygnus X3, believed to be a Wolf-Rayet star, orbited by a massive radio source, which I won't refer to as a neutron star. Now, we've left links to this article here about Cygnus X3. It is disputed as to the distance to Cygnus X3, in that it's very difficult to calculate the distance to an object which is massive and which you are viewing its ecliptic plane. If you're looking right at its poloidal fields, it will have a tendency to be very bright and very difficult to measure. That said, please read this article about the mystery of Cygnus X3 from andrewcollins.com and the cosmic ray question. Now, we've cited this article before, and it is a very in-depth article. Cygnus X3 is a super important X-ray, gamma ray, cosmic ray source, and there's a lot of information in this article. Let's just read some of the conclusions. Despite the Pseudon and Nusex observations of an increased muon flux underground during the 1980s remaining controversial, there exists good evidence for the existence of long-lived, low-mass, strongly interacting neutral primaries from Cygnus X3. Exotic primaries have been proposed to explain the related EAS and increased muon flux underground with strange quark matter from a strange matter compact star. Anyway, let's just say it's not understood yet, and it's a local blazar. It is expected to be about between 20 and 40,000 light years away. However, when we're talking about relativistic jets, as we see from all kinds of objects, that's not a great distance depending on the amount of energy. Let me just elaborate here. First of all, let's look at where Cygnus X3 lies in the galaxy. Now, this is an image, obviously, from a perspective that we don't have within the galaxy. Let me draw a bright green line here. So this would be you viewing the galactic core. You're looking in this direction. That's the direction you're looking at if you're looking at Sagittarius A star. If you're looking at Gaminga Pulsar and the Crab Nebula, those are out in this direction. Cygnus is out in this direction. And if the Milky Way is a barred spiral galaxy, there's a distinct possibility that the bar connects to Cygnus. It wouldn't be surprising at all to know that the energy from Sagittarius A star is being sent to the Milky Way galaxy, to our solar system, via the Cygnus arm somehow. Now, is it possible that X3 has some sort of important stuff to do with Earth, the catastrophe cycle? Is it a coincidence that it just happens to be the other celestial North Pole? That is the star Deneb, otherwise known as Cygnus X3 in the constellation Cygnus, which, by the way, circles around the North Pole all the time. If you're in the Northern Hemisphere, Cygnus X3 is constantly circling the North Pole. So let's just take a look at what must be going on. There must be some sort of a beam, probably a proton beam, headed all the way through space, 20,000 plus light years, from Cygnus to where your backyard is. That's why I'm drawing in this blue thing, this blue and red spiral here, because that would cause a galactic spoke to be created. As this object goes around the galactic core, so do we go along the galactic core, and that means that this spoke probably extends halfway around the galaxy as the Earth wobbles back and forth through its precessional cycle. And let's just keep that in quotes for reasons that I won't get into during this segment. There's some sort of important connection between Cygnus X3 and Earth's cosmology. Now, when you view Cygnus X3 through different wavelengths, this includes optical, radio, which is the blue and red, as well as X-ray, which is the super bright regions, which are essentially covering up the optical range. This blue jet right here, this is the portion of Cygnus's jet that's aimed toward you. This jet down here, this is the part of the beam that's in the background, oriented away from you. In order for this thing's pole to be sending you a constant beam like this, there has to be essentially a Birkeland current traveling all the way through the galaxy, probably looking something like this. And of course, there would be a secondary current going like this. As we know that the primary output of stars, and most likely galaxies also, is the proton. What happens when they get accelerated to relativistic speeds by active objects? We're not exactly sure, but we see evidence of things making it all the way from there to here, literally passing cosmic rays through your brain. Now, when we view an active galaxy, and again, Cygnus is not an active galaxy, it's just a big star. Again, probably the most luminous object visible from our solar system, the most intrinsically luminous object. It's kind of like a blazar within the galaxy. When you look at a galaxy from the ecliptic plane, the reason that this appears active is because you're looking down the poloidal field. In other words, there's a field like this, and it's aimed at you. And that completely changes the perspective. So, what is a blazar? A blazar is an object, and in this case, a true blazar would be an active galactic nucleus. When you look at one of these things, it just looks like a very bright point of light. But when you try to measure its distance, it appears to be very, very distant. And all of these things have some sort of intrinsic wobble. So, how does this relate to Cygnus X3? Well, Cygnus X3 has something to do with the precessional cycle. What does it have to do with the precessional cycle and the catastrophe cycle? Not exactly sure, but it is an interesting source of information, to say the least. Now, X3 was discovered back in the 70s with underground radiation detectors, and its periodicity is super important. It has a 4.8-hour periodicity, where the massive radio source is believed to be orbiting the Wolf-Rayet star, siphoning a massive amount of material out of it, and creating a solar wind approximately 10 times the density and temperature and speed of the local yellow dwarf's solar wind. So please read the article, especially this AndrewCollins.com article. It's got all kinds of references to other articles about X3. And this is an odd thing that we're having lots of trouble getting anybody to talk about, as it refutes lots of theories and supports lots of highly misunderstood theories. I also included an image of M87 here. This is the black hole, which we're still going to just refer to as a massive radio source. And we're looking kind of along its jet. And let me just explain. This galaxy would be a blazar if we were inside of this jet. And another thing I find interesting here is you see these pulses. You see there's like a pulse here, and then there's seemingly empty space, and then there's a pulse here, and then there's seemingly empty space, and then there's a pulse here, seemingly empty space. There is an electron bridge in between all of those areas. And let's just leave it at that and move on to this phys.org article talking about blazar variability. So, there are two reasons we can have blazar variability. It's because, one, the beam is no longer pointing directly at the observer, or because its activity is really changing. And those two things are super important when it comes to the motions of stars and galaxies especially. I believe that BLAZARS are the key to understanding cosmology, so please read this article on phys.org about BLAZAR variability. By the way, the BLAZAR they're talking about is 4C11.69, and we did indeed find it on the Neil Gorell's Bat Swift Observatory. Just type in 4C11.69, the catchy name. Probably 11.69 I'll find it. And I don't know, I'm unable to type today. It's also known as CTA 102. And there are the transients. And I would note that we actually saw a much beefier X-ray transient come out of this thing in 2018 than we saw in 2016, which is what the article's about. So another interesting feature here is the variability of X-rays versus gamma rays versus radio frequency versus infrared frequency. We'll leave links to that below the video, as well as to this article about the nature of the flux and so on. These are some very, very high energy objects, especially when you're looking down the poloidal field. Here it is on Simbad, and we'll leave links to that as well once we get the video uploaded to YouTube, as well as to the Wikipedia page. An interesting blazar, to say the least, and all blazars are super interesting, as they may be playing pickup sticks with your stellar environment. Are you familiar with the smAsho mission? We've begun the process of starting a nonprofit organization in order to assist, study, and report on the ongoing formation of a unified theory of physics. And we need lots of funding to continue doing what we're doing. Also, to raise the awareness of the general public of the relationship between space weather and Earth effects. Also, to connect and to consult with media organizations to multiply our reach, hence videos like this, to demonstrate cutting-edge proof-of-concept solutions to problems. And we're growing tomatoes indoors right now, which we brought in from outdoors once again, to publish scientific papers in a multidisciplinary manner, where we'll be talking about things like polarization pathways and ionization pathways and other stuff that doesn't seem to be understood by cosmology, at least mainstream cosmology. And we'll be publishing papers also in the sciences, including but not limited to spectroscopy and chemistry and astrophysics and health and wellness and longevity, cosmology, biology, pretty much anything that relates to the mission. Also to assist mankind, the humans, by advancing the study of gold-pressed latinum and predictive phenomena in order to optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is. And lastly, to not be ossified in our beliefs and treat those who are with love, respect, and inclusion to the scientific discussion. Because that's what science is, folks. Don't be ossified in your beliefs. If you're not willing to change your mind, you're not doing science. You're doing dogma. So check out smashomash.org, sign up for the forum, and talk about anything you want on our servers. We won't censor you, so don't make a fool of yourself. And please donate to the cause via Patreon, patreon.com/smashomash, the true source of funding. And thanks again, Smash Team, for staying tuned for more stuff. Now, our next live stream that we have planned, the next special event at least, is planned for March 19th at 11:49 p.m., the March equinox, where it becomes fall in the southern hemisphere and where it becomes spring where I'm at. If you watched our New Year's Eve special, then there's nothing to tell you about this. But if you didn't, perhaps check out our New Year's Eve stream, which we streamed live to YouTube and to Twitch in different formats, and we've just released the screen capture view onto YouTube. So if you want to watch that, I'll link that below the video as well once I'm done live streaming here. And again, thanks everybody on Twitch. Let me see if I can get through the comments. No, Mary, radio sources are not necessarily the creatings of star nurseries. Radio sources, everything emits radio pretty much. And typically what's believed by mainstream astronomy is that X-rays, when we look at the halo of a galaxy, we're looking for X-rays for the birth of stars. By the way, if I haven't said Happy New Year to you yet, Happy New Year, 2020. It's 2020, folks. Any interesting plans for 2020? Have you made a resolution? I've made a resolution. It's to be a slightly less terrible bicycle mechanic, as I've got more bikes that don't work than ones that do work right now. And I've got to get on that, as I've been slacking in all kinds of ways. So let us know. Leave a comment what your New Year's resolution is, if anything. Let's look at the latest image of SUNSPOT 2755, which is getting named late. And we're going to end up with a sunspot-free day just because somebody didn't name this sunspot. I don't know how it works. It is an interesting thing, to say the least. And it's got like a double umbra thing going on there in the leading umbra, and a very weak trailing umbra. But nonetheless, cycle 25 sunspot all day. Look how low the latitude is. I mean, how high the latitude is. How far from the equator it is the point. Here's the view, the latest view, in colorized magnetogram. And that's going to be a beta class sunspot, as there are two umbrae, most likely of opposite polarities. And let's break out a 48-hour view here and call it a day. I don't know how I got that. Here's a 48-hour view in 171 angstroms, full resolution. Thanks again for tuning in, folks. Please don't forget to press like and subscribe wherever you're at. Please share the videos on your social media, as we've got a lot of stuff to do this year, and the more people that view the videos, the better off we'll be at doing it. Don't hold your breath for Sunspot 2755 to get named, but if you're guessing names, guess it's going to be named 2755, as that's absolutely what it's going to be named. We are out. And in closing, may that solar wind be at your back and that atherosclerosis absent from your veins.